All right, so here we are. We're going to take a look at Pre-Calculus 30, section 6.3, number 2. And of course, we're talking about trigonometric identities. We're working at proving identities. And this question asks us to use factoring to help to prove each identity for all the permissible values for x. So we're going to use factoring to prove that for a, this side is equal to this side. Okay? And so, not the A, of course. But what we want to do is and I've written it down over here. What we want to do is we want to focus on the more complicated side because there's just more to work with. There's more things that you can manipulate and change into other identities and such. So work with the more complicated side. And what we see here, the first thing that jumps out to me is that we have a cos x as a common factor in these two terms. So I'm going to pull out a cos x here. And when I divide that out of these two terms, I'm going to be left with a 1 plus tan squared x. Okay? Now, don't get fooled by this equal sign, okay? We are not assuming that these are equal. We're proving they're equal. So what that means is, like, you can't multiply both sides of this statement by the same thing, or add or subtract both sides. So as soon as you start to mix left side and right side, you're treating it as an equation, which we cannot do. We have to focus on one side only and then rearrange that, manipulate that so that it looks like the second side. Then we can say it's proved for all permissible values of x. We can say, insert any value there that's permissible and the left side will equal the right side. It is an identity. So that's what we're working on. So we're just working on the left side. Now, what you'll notice here, 1 plus tan squared x, you should see that over here in one of our Pythagorean identities, we have 1 plus tan squared x, and that equals secant squared x. So I'm going to substitute this second part here. I'm going to replace that with secant squared x. Okay. Now, why is that important? Well, you do have to have some kind of foresight, okay? You have to kind of take a look and say, okay, this is where I want to be. I want to be at secant x. So if I can change this right here into something secant, that's probably a good thing. And indeed it is. So we have secant squared and we have this cos here. Well, remember that secant squared x is the same as 1 over cos squared x. Or, seeing as we want to end up with a secant x, let's change cos x into 1 over secant x. And then look at what we have here. So now I have 1 over secant x times secant squared x. Well, that's the same as secant squared x over secant x, right? Cos secant, yeah, over secant x. And so if I simplify that, remember this is secant x times secant x all over secant x, okay? So really I can, because they're factors, I can eliminate 1 and you're left with secant x. And there you go. You've got the left side after this manipulation equal to the right side, so you have proven QED. It's done. All right? So there's 6.3, number 2A. And again, here are your identities on the right there. So there's a little question for you from your homework.